Let us do some multiple choice questions on alkenes. Question number 1 is number of structural isomers of pentene is. Number of structural isomers of pentene. Option 1, 1, option 2, 2, option 3, 3 and option 4, 5 isomers. Let us try to find out how many isomers are possible for pentene. This is 1, then you can have 2 pentene, you can have 2 methyl butanene, you can have 3 methyl butanene, and the other possibility is this 2 butene, 2 methyl 2 butene. So, these are the 5 isomers possible for pentene. For question number 1, the correct answer is fourth option, that is 5 isomers are possible. Question number 2, electrolysis of this aqueous solution gives ethene at anode. Ethene at anode. First option sodium acetate, second option disodium succinate, third option sodium fumarate, and fourth option is sodium maleate. Let us find out what is the correct answer. The correct answer is second option, disodium succinate. I am going to look at show you the equation. This is disodium succinate. This is disodium succinate. On electrolysis, it will give ethene, 2 moles of carbon dioxide, and NaOH. Of course, you get hydrogen gas also. So, the correct answer is disodium succinate is second option. So, the correct answer is second option. Question number 3. Look at the equation. You have 2 bromopentane and it is being treated with some reagent and you are getting 2 pentene as a major product, and we are asked to find out what is the reagent used for the equation. Aqueous KOH is first option, second option is Lindlar's catalyst, ranitidine is third option, and fourth option is alcoholic KOH. And the correct answer is alcoholic KOH because the reaction is dehydrohalogenation. So, the correct answer is fourth option, alcoholic KOH. Look at this. This is the substance given in the equation. It is supposed to undergo dehydrohalogenation to transform into this, and this requires alcoholic KOH. Here there are 2 possibilities. Hydrogen may be lost from the C1 or C3, but preferably it is lost from C3 on the basis of Sedgwick's rule, which says that hydrogen is removed from the carbon having lesser number of hydrogens. While this carbon has got 3 hydrogens, this carbon has got only 2 hydrogens. So, preferably this carbon will lose hydrogen. So, the correct answer is fourth option, alcoholic KOH. The reaction is called dehydrohalogenation. Question number 4. Vicinal dihalides, when they are treated with zinc metal, what do you get? Options are alkane, second option alkene, third option alkynes, and fourth option arene. Look at this. This is a vicinal dihalide. It has 2 halogen atoms on adjacent carbon atoms. When this is heated with zinc dust, you lose halogens as ZnCl2 and you end up with alkene. It is an alkene. So, the correct answer is second option, alkene. Question number 5. Some equation is given and you are asked to find out the major product in the equation. The compound given in the question is 2-pentanol and the reagent is concentrated sulfuric acid. The reaction which is expected to take place is loss of water and you end up with alkene. So, the correct answer is second option, pent-2-ene. Third and fourth options are ruled out on the basis of number of carbons. You are left out with first and second option. First option is Hoffman's product and second option is Setzer's product. Here Setzer's product is major because it is more substituted alkene. So, answer is second option because major product is asked. Question number 6. Addition of hydrogen halides on alkenes follows this order. First option HCl greater than HBr greater than HI. Second option HBr greater than HCl greater than HI. Third option HI greater than HBr greater than HCl. Fourth option is HCl greater than HBr greater than HI, and the correct answer is third option HI greater than HBr greater than HCl, and the reason is strength of acid. As the acidic strength increases, the reactivity towards alkene increases, because the first step is gain of H plus. So, the acid which can produce H plus most readily will be most reactive. HI is the strongest acid because of weakest bond strength when compared to HBr and HCl. Answer is third option. Question number 7. Propene is made to react with HBr in presence of peroxide. The major product in the above reaction is first option is 1-bromopropane, second option is 2-bromopropane, third option is allyl bromide, and fourth option is vinyl bromide. See, in presence of peroxide, anti-Markovnikov addition of HBr takes place. That means H goes to the carbon having less number of hydrogens and Br goes to the carbon having more number of hydrogens. So, that is anti-Markovnikov's addition. I will write the equation: CH3 single bond CH double bond CH2. What is being added is HBr, then H goes to the carbon having lesser number of hydrogens. And Br goes to the carbon having more number of hydrogens. This is 1-bromopropane. So, the correct answer is first option 1-bromopropane. Question number 8. Decolorization of bromine solution indicates first option unsaturation, second option saturation, third option aromatic system, fourth option cyclic system. We know that unsaturated systems decolorize Bayer's reagent as well as bromine water. So, the correct answer is unsaturation. Decolorization of bromine is done by unsaturated systems having double bonds and triple bonds. So, the correct answer is option 1, unsaturation. Question number 9. The unsaturated hydrocarbon forms aldehyde and ketone on ozonolysis. Now, we have to identify the hydrocarbon which can give aldehyde and ketone on ozonolysis. Look at the options. First option given is RCH double bond CH R dash. The overall reaction of ozonolysis is breaking of CC double bond, and you need to put 2 oxygens on either side. So, you get RCHO and R dash CHO, both are aldehydes. So, first option is ruled out. Look at the second option, R2C double bond C R dash 2. When this breaks, this will give 2 moles of ketone. RC double bond OR, this is a ketone, then R dash C double bond OR dash, this is also a ketone. So, second option is also ruled out. We are looking for that option which can give 1 mole of aldehyde and 1 mole of ketone. Look at the third option, R2C double bond CH R dash. This on ozonolysis gives ketone and R dash CHO aldehyde. So, the correct answer is third option. Whereas, our fourth option CH2 double bond CH2, this will break to give 2 moles of formaldehyde. So, the correct answer is third option. It is this compound which can give 1 mole of ketone and 1 mole of aldehyde upon ozonolysis. Question number 10. Rate of dehydrohalogenation with respect to halogen is. See, this is dehydrohalogenation. Base will abstract this and this will knock out H, and X will be knocked out like this, and you end up with alkene. This is dehydrohalogenation. The rate depends upon strength of, this is common for all the substances, the rate depends on the strength of CX bond. So, the correct answer is I greater than Br greater than Cl. The reason is Ci bond is weaker than Cbr, Cbr is weaker than Ccl. So, the rate is I greater than Br, Br greater than Cl. Reason is strength of bond. So, the correct answer is first option. Question number 11. Hydration of isobutene in acidic medium forms. First option isobutane, second option isobutyl alcohol, third option terbutyl alcohol, and fourth isobutane. Let's look at the reaction. Isobutene can be written like this. When this undergoes hydration, you end up with this. This is tertiary butyl alcohol. The reaction proceeds via carbocation intermediate, and tertiary carbocation is formed, which is attacked by water molecule. Subsequently, there is loss of H plus to give tertiary butyl alcohol. So, the correct answer is tertiary butyl alcohol, third option. Question number 12. Propene plus chlorine at 500 degrees Celsius gives what? First option 3 chloropropane, second option 2 chloropropene, third 1,2 dichloropropane, and fourth option is vinyl chloride. Look at the reaction. CH3 CH double bond CH2. Chlorine, and you are using very high temperature condition 500 degrees Celsius. This will bring about homolytic cleavage of chlorine molecule, and allylic chlorination takes place. If you number it 1, 2, 3, so the product is 3 chloropropene. 3 chloropropene, so the correct answer is first option. Allylic chlorination takes place. Allylic chlorination, it is a case of free radical substitution. It is a case of free radical substitution. Question number 13. Cis-trans isomers differ in A. configuration, B. physical properties, C. dipole moment, and D. molecular mass. And the options given are first option AB, second option ABC, third option CD, and fourth option AD. Actually, cis-trans isomers, they not only differ in their configuration, they differ in their physical properties as well as dipole moment. So, the correct answer is second option A, B, and C. Question number 14. Alkenes exhibit A. chain isomerism, B. ring chain isomerism, C. cis-trans isomerism, D. metamerism. And the correct answer is A, B, and C. First option A, B, and C. They exhibit chain, ring chain, and cis-trans isomerism. I will show you. These two are related to each other as chain isomers. Well, these two are related to each other as ring chain isomers. Butene and cyclobutane are ring chain isomers, whereas these two are, this is trans and this is cis. These two are a case of cis-trans isomers. So, alkenes can exhibit these three types of isomerism: chain, ring chain, and cis-trans isomers. The correct answer is first option A, B, C. Question number 15. Markovnikov's rule is not applicable to A. ethene, B. 2-butene, C. 1-butene, and D. propene. Remember, Markovnikov's rule is not applicable for symmetrical alkenes. It is applicable only for unsymmetrical alkenes. When you look at the options, you realize that ethene and 2-butene are symmetrical alkenes. So, the correct answer must be AB. First option, AB. Ethene and 2-butene are symmetrical alkenes. These two, you have same number of hydrogens on either side. So, these two are symmetrical alkenes. For symmetrical alkenes, Markovnikov's rule is not valid. It will not be applicable for symmetrical alkenes. Question number 16. The unsaturation in the compound can be detected by addition of A. Bayer's reagent, B. bromine in carbon tetrachloride, C. acidified water, and D. HBr. If you look at the options, you realize that the first and second, A and B, are colored substances. They undergo decolorization. So, the correct answer is AB, that is first option. Bromine water is decolorized, Bayer's reagent is also decolorized by unsaturated compounds. So, the correct answer is first option, A and B. Question number 17. This is an assertion reason type of question. The relative rates of hydrogenation decrease as follows: ethene greater than monosubstituted alkene, then disubstituted alkene. Reason is steric hindrance of alkyl groups. Actually, this is a correct rate of correct order of rate of hydrogenation. Ethene undergoes hydrogenation more readily than the monosubstituted alkene, which is more reactive than disubstituted alkene. And the reason given is also correct. Steric hindrance is the factor. So, the correct answer is first option. Both A and R are true, and R is the correct explanation of A. Steric reason can be taken as a correct reason for this. Question number 18. This is also assertion reason type of question. Assertion is an equation given: propene plus HBr gives 1 bromopropane, that is in presence of peroxide, anti-Markovnikov addition. This is correct, assertion is correct. And reason: in the presence of peroxide, anti-Markovnikov addition of HBr is observed. This is also correct, and a correct explanation also. So, you can say the correct answer is first option. Question number 19. Trans-alkene assertion is trans-alkene has higher melting point than cis-alkene. This is a fact. Boiling point of cis-alkene is greater than trans-alkene. If you compare boiling point, cis is greater than trans, and the reason is dipole moment. Cis has finite dipole moment and trans will be either non-polar or less polar. When it comes to melting point, it is trans which is greater than cis. So, assertion is correct. Then reason given is trans-alkene can be symmetrically packed in crystal lattice. So, it is possible to pack more efficiently. Trans-alkene can be packed more efficiently in the crystal, therefore, its melting point is high. So, the correct answer can be taken as first option. Question number 20, assertion reason type. Addition of HBr to but1ene gives two optical isomers. Addition of HBr to but1ene. This is but1ene and you are adding HBr. The product is this. And then the second option is the product contains one asymmetric carbon. This is also correct. This is an asymmetric carbon. Because of this, it will exist in two forms, plus and minus. That is the reason why correct answer is first option only. Because of one asymmetric carbon, it exists in two isomeric forms. Those are stereoisomers or enantiomers. Question number 21. In the list 1, some reagents are given, and in the list 2, the type of reaction they bring about. Alcoholic KOH, concentrated sulfuric acid, Bayer's reagent, and zinc in alcohol. These are the reagents given, and on the other side you have dehalogenation, test for unsaturation, dehydration, and dehydrohalogenation. See, alcoholic KOH brings about dehydrohalogenation, so A should be matched with 4. Concentrated sulfuric acid brings about dehydration, so B should be matched with 3. Zinc, Bayer's reagent is used for testing unsaturation, so C should be matched with 2, and zinc in alcohol can bring about dehalogenation, D should be matched with 1. Therefore, the correct answer is second option, A4, B3, C2, and D1. Question number 22. In the list 1 you have some compounds and list 2 some products are given on ozonolysis. Let us try one by one. Ethene is given, this is ethene. Ethene on ozonolysis gives rise to 2 moles of formaldehyde. So, A should be matched with 4. Then propene is given. This on ozonolysis gives acetaldehyde, ethanol and formaldehyde. So, B should be matched with 3. Then butanene. Butanene gives propanol and formaldehyde. So, this should be matched with second option. D, butene. This on ozonolysis gives, it cleaves here and gives 2 moles of acetaldehyde. So, D should be matched with 1. So, the correct answer is third option. Question number 23. Reactions are given in list 1 and you have to match them with the product given in the list 2. A is CH3 taken thrice Cl, and what is being done is it is being treated with alcoholic KOH. When you treat it with alcoholic KOH, you end up with dehydrohalogenated product, and this is isobutene or 2-methyl-propanene. So, it should be matched with first option. Then B is CH3 taken thrice CCHOH CH3. This is being treated with concentrated sulfuric acid, and you are asked to find out what is the product obtained. First, this will be lost as water by protonation of this, and then methyl migration takes place. So, you end up with CH3 CH3 plus this is formed first, this will be lost as water and that will lead to rearrangement. Methyl shift takes place, CH3 CH3 plus, subsequently there is loss of H plus and you end up with this product. This is 2,3-dimethyl 2,3-dimethyl butene. Now, the next reaction C is CH3 taken thrice C, CHCl CH3. This is being treated with alcoholic KOH. Dehydrohalogenation takes place and you simply get a double bond here. This is the product. So, you can name it as, I will write the full structure. This is 3,3-dimethyl butanene. So, this should be matched with the second option, and the last one is 1,2-dibromoethane. It will undergo dehalogenation in presence of zinc to give ethene. So, that should be D should be matched with 3. So, the correct answer is fourth option. Question number 24. Some reactions are given in list 1 and you are asked to match with the product given in the list 2. Reactions are given in list 1. First reaction is like this. This is the reactant and it is being treated with ozone. Ozonolysis is being done. So, the product will be acetone plus acetaldehyde. So, A should be therefore match with 5. Then next reaction is hydration reaction. This is isobutylene and it is subjected to hydration. You get this. This is tertiary butyl alcohol. So, it should be matched with 3. B should be matched with 3. Then C, reaction C is it has butene which is being treated with cold alkaline KMnO4. This is Bayer's reagent and it brings about cis hydroxylation. Hydroxylation means 2 OH groups get added across the double bond. Then finally, and this should be C should be matched with 2, that is butane 2,3-diol. And finally, D, this consists of propene. Propene is being treated with silver in presence of oxygen. So, epoxidation takes place and you get propylene epoxide. It should be matched with propylene oxide. So, the correct answer therefore is third option. Question number 25. Here also some reactions are given on the other side. You need to identify the type of change taking place in each case. Butene is subjected to oxidation with cold KMnO4. Butene, cold alkaline KMnO4. This is a case of hydroxylation. So, A should be matched with cis addition because it is a case of cis hydroxylation. So, it is a case of cis addition. B, this time butene is being treated with bromine. So, bromine gets added across the double bond and it is a case of anti-addition. So, this should be matched with anti-addition of bromine. It takes place via cyclic bromonium ion, therefore, it is an anti-addition. 1,1-dibromoethane. This is 1,1-dibromoethane. It is being treated with soda amide. So, it will give rise to HC triple bond CH. So, it is a case of elimination. So, you can match it with beta elimination. H and Br are added, H and Br are lost from adjacent carbon atoms, therefore, it is beta elimination. So, C should be matched with 4 and then finally, ozonolysis of alkene. This is a case of oxidative cleavage. So, D should be matched with 5. So, the correct answer is second option. Question number 26. A reaction is given and you are asked to find out the product formed in the reaction. I will write down the equation CH3 CCH3, then you have a double bond and then CH3. What is being added is HCl, and remember this is a case of Markovnikov addition. So, Cl goes to the carbon having lesser number of hydrogens. So, it is this carbon which receives chlorine. So, you get, obviously this carbon receives H, CH3 CCl CH3 CH2 CH3. Now, let us try to name this 1, 2, 3, 4. So, it is 2 chloro 2 methyl butane. This is the product. Markovnikov addition takes place. So, the correct answer is third option, 2 chloro 2 methyl butane. That is all in this discussion. Thank you.